हेलो गाइस, कैसे हैं सब लोग? वी आर सो बैक एंड वी आर बैक आफ्टर वॉचिंग द मूवी ओडेसी। डैम, ओडेसी एकदम वॉर टाइप मूवी थी। एंड गेस व्हाट, मूवी देखने के बाद एकदम नींद आ गई। हेलो
वो
गाइस, कैसे हैं सब लोग? फाइन, वी आर बैक एट द स्ट्रीम। आज हम करेंगे क्विक शॉट। भाई आज की प्लानिंग बहुत तगड़ी थी हमारी, बट द थिंग इट्स मैंने खुद के ही पैर पे कुल्हाड़ी मार ली। या I told you right, post Odyssey. Well, okay, let's as a tribute to Christopher Nolan. Wait, आज हम कुछ अलग करेंगे, रुक जा। Odyssey poster. Hmm. Well, okay. Okay, so where is it? नहीं हो रहा, पेस्ट नहीं हो रहा। के हम करेंगे ये Odyssey मूवी को। आज हम ट्रिब्यूट देंगे क्रिस्टोफर नोलन को फॉर मेकिंग सच अ गुड विजुअलिस्टिक मूवी। ओवरऑल मूवी तो बहुत ठीक थी, बट विजुअली अपीलिंग थी। आई फील बहुत सारी चीजें हो सकते थे ऐड, बट आई डोंट नो व्हाई डिडंट ही डू इट। एनीवेज, लेट्स गेट स्टार्टेड विद आवर स्ट्रीम गाइस। आज हम करेंगे क्विक शॉट। क्विक शॉट के बाद वी हैव डन ऑल टाइप्स ऑफ शॉट। द थिंग इज, इनका ड्राई रन मैं ना अपने फ्री टाइम में करूंगा। लाइक मर्ज शॉट भी समझ आ गया, बट द थिंग इज आई स्किप बिट ऑफ पार्ट एंड देन आएगा अपना क्विक शॉट। इंसर्शन शॉट का भी ड्राई रन बचा है एंड ऑल। ये बात है यार, ये करना है एक्चुअली। सो व्हाट आर वी वेटिंग फॉर यार? वी आर वेटिंग फॉर नो वन। So if we are waiting for no one, then why should we not start? Let's start it. Okay, so let's go.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another video from the Strivers A to Z DSA course. Just in case you don't know about this, and if for the first time here, this is world's most in-depth DS algo course. Why do I say that? Because you can go over the entire internet. You can buy any of the paid courses in the market. None of them will be covering any DS algo stuff in such depth. This course has 456 modules and you'll be covering 400 plus problems in this particular course itself. So once you complete the course, you will be ready for any of the DS algo rounds in any of the companies in any part of the world. That is my guarantee to you. So in this video, we will be learning about quick sort. What about these couple of topics? Now, these couple of topics are very self-explanatory. So what I will be doing is I'll be adding notes to them so that once you go through the entire notes, you will be able to understand that by yourself. A video is not required for these couple of topics. So that's why I will not be adding videos. So in this video, we will be talking about quick sort. So without waiting, let's get started. Quick sort algorithm. What does the algorithm do? Very obvious to guess. Yes, it does sort any of the given data structure in an ascending order. But if you do some minor tweaks to it, yes, if you do some minor tweaks to it, it will be also sorting it in an descending order. So in this video, I'll be teaching you the quick sort algorithm that sorts the given data structure in an ascending order in depth so that you can do the minor tweaks by yourself and you can sort the data structure in a descending order as well. So what will be the flow of the lecture? Very simple. First, I'll be explaining the algorithm. Then I'll be telling you the intuition behind every step of the algorithm. Once we are done with that, we'll be going and writing the pseudocode. Now remember one thing, I'll be writing the pseudocode in such a way that you can code it in C++, Java, Python, or any of the programming languages you code in. So this tutorial is going to be language independent. And then we will be doing a dry run on the pseudocode so that the recursion is clear on your head. Once these three steps are done, we'll be moving to the online compiler and compiling it so that you get an essence of the online compiler. Post that, I'll be discussing the time complexity and the space complexity as well. So you must be thinking, but Striver, wait, we already know about the merge sort algorithm, which has a time complexity of n log n and has a space complexity of big O of n, where we use an extra temporary array. Why quicksort? So quicksort has a time complexity similar to merge n log n, but doesn't uses any extra temporary array. Yes, it uses recursion stack space, but no temporary array. So quicksort is slightly better than merge sort, but does that mean you don't need to know merge? No, you need to, because there are a lot of problems which can be solved just by using merge. And we will be seeing that in the arrays playlist when we will be solving problems related to merge sort. So it's very important that you understand all the sorting algorithms because you never know. In an interview, the interviewer might ask you any of the sorting algorithms, might ask you any question that might be similar to a particular sorting algorithm. So do not skip any of the sorting algorithms. That is what my recommendation to you will be. So let's get into the explanation of the algorithm, and we will be using this particular array as an example to understand the algorithm. So the first step of the algorithm is very simple. If you're given an array The first step is very simple. Pick a pivot. Remember this. Pick a pivot. What is a pivot? Pivot can be any element in the array. Any element. Can be the first element, can be the last, can be the median, can be the random, or can be any element by your choice. Any element by your choice. There is no particular rule to pick a pivot. No particular rule. Now, once you have picked the pivot, so for an example, we say that we will be following the first rule and we'll be picking up the pivot as the first element of any given array to us. So we'll be like, okay, we're given this array. So we will be picking up the pivot as 4. That is my job. I'll say, okay, we're given this array. So I'll be picking pivot as 4, first element of the array. What after that? Pick that element and place it in its correct place in the sorted array. What does it mean? Now, this array is unsorted. Agreed? But if I have to ask you, what is the sorted array? Can I say the sorted array will be 1, 2, 3, 4, 5, 6, 7? Can I? And if I have to write it, will it be something like 1, 2, 3, 4, 5, 6, 7, 9? And if I ask you, what is the correct place of 4? If I have to ask you, what is the correct place of 4? You'll be saying, correct place of 4 is this, which is the fourth place. It is currently lying at the first place. But actually, the correct place of 4 is at the fourth place. That is what you'll do. You'll pick up 4 and you'll say, picked up an element and place it in its correct place. And just take it and place it in its correct place. That is what you have to do. Pick up a pivot and place it in its correct place. Now, how will that help? Let's understand. I said, pick a pivot. So you picked up 4 and you placed it in its correct place. Done. Then you picked up 6 for an example, just for example, and you placed it at its correct place, which is this. Then you picked up 2 and placed it at its correct place. Then you picked up 5 and placed it at its correct place. Then you picked up 7 and placed it at its correct place. Then you picked up 9 and placed it at its correct place. Then you picked up 1 and placed it at its correct place. Then you picked up 3 and placed it at its correct place. So will the array be sorted at the end of the day? That is the reason. The intuition was very simple. Pick up a pivot, and pivot can be anything. Doesn't matter what you pick, because at the end of the day, if you're putting them into its correct place and every element is put, the array will be sorted. It doesn't matter what you pick. As long as you're putting them into the correct place, at the end of the day, if I've picked up every element, the array will be sorted. That's the reason any of them will work. But we will go with first element. You can go with the last, median, whatever you wish to. Okay, so we've understood the algorithm. Pick up a pivot and place it in its correct place in the sorted array. But what happens to other elements? So the rule is, step number 2 is very simple. Smaller on the left, remember this, smaller on the left and larger on the right. How? I'll explain you that afterwards. But as of now, just understand the explanation and the intuition of the algorithm. Smaller on the left and the larger on the right. So what are the smallest? Is 6 smaller? No. So 6 will go on the right. Is 2 smaller? Yes, on the left. Is 5 smaller? No, greater. So goes on the right. Is 7 smaller? No. So goes on the right. Is 9 smaller? No. Goes on the right. Smaller? No. And how? Smaller on the left and larger on the right. How? I'll explain you that afterwards. But as of now, just understand the explanation and the intuition of the algorithm. Smaller on the left and the larger on the right. So what are the smallest? Is 6 smaller? No. So 6 will go on the right. Is 2 smaller? Yes, on the left. Is 5 smaller? No, greater. So goes on the right. Is 7 smaller? No. So goes on the right. Is 9 smaller? No. Goes on the right. Is 1 smaller? Yes. Is 3 smaller? Yes. So if you see, can I say I have 2, 1, 3 and I have 6, 5, 7, 9. So these are greater and these are smaller. And can I say after one step, can I say this, that one element is at its correct place in the array? I can. So what is left? Can I say the left portion is still an unsorted and the right portion is still unsorted? Now, why is the step? What is the intuition behind smaller on the left and larger on the right? If you think, in a very logical manner, if 4 is at its correct place, the left guys to the 4 in the sorted array will be smaller and the right guys will be greater. That's why it's logical to say smaller go on the left and larger go on the right. So that's the intuition behind the step 2. You have understood the intuition behind both the steps. Now, what you need to do is repeat these steps. Repeat these steps again and again. And how do you do that? Very simple. Can I say 4 is done? What is left? The left portion and the right portion. Let's take the left portion, 2, 1, 3. Can I say it's an individual array? It is. So let's take that individual array, 2, 1, 3. And let's again apply the same rules. What is the step 1? Pick a pivot. What is our rule? First element. Let's go and pick up the first element as a pivot. 2. If I ask you the correct order, if I have to write the sorted array, can I say this will be the sorted array? Can I say the correct order of 2 will be here, thereby? Step 2. Correct order, I put it. I've picked up a pivot and put it into the correct order. Step 2. Small on the left.
Guys, 2 minutes, 2 minutes. मेरे पैर गंदे हैं, like 2 मिनट में wash करके Just a minute. So we are back, guys. Again on screen. Let's continue.
So one is smaller on the left, three is larger on the right. So can I say two is done and we're left with one and three? So again, two smaller arrays. But whenever an array has one element, no need to do anything. Why? One element is sorted in itself. So can I say at the end, you made this array to one, two, three. So at the original places, this will change, and this will change. So the left guy got sorted. That's the time for the right guy, 6579. So let's do it for the right guy as well, 6579. So I'll write it 6579. Rule one on this array. Yes. So I did it very simple. 4 was done. Did the same algorithm on the left, did the same algorithm on the right. So kind of recursion. Kind of get an idea of recursion. Take the array, get the pivot, do everything, then call it for the left, call it for the right. Kind of, you getting this? Yes. Next. What's the next stop for the right array? 6578. What's your pivot? 6. We have to hypothetically, again, same rule, hypothetically. We have to write it. What will be it? 5, 6, 7, 8. So what's the correct order of 6? Yes. This one. Smaller on the,
I was sort of coming
larger on the right.
Avinash.
So can I say two arrays again? 5, 7, 9. So can I hypothetically say that 6 was placed at its, and can I say 5? Go ahead and say 6 was placed at its correct place, right? And can I say 5? Can I say 5 is a single array? So 5 is also placed at its correct place? I can. What is left? This 7, 9. So again, another array. So let's take this 7, 9 as another array. I can. What is left? This 7, 9. So again, another array. So let's take this 7, 9 as another array. Again, pick up a pivot. 7 is the pivot. What's the correct place of pivot? 7 itself. And the other one is 9, which is the greater. So on the right. So 7 is placed. Again, go ahead and say 7 is done. And now 9 is the single element. That's also done. So at the end, can I say this is also sorted? So at the end, can I say the array automatically did it for all the elements and each of them is at its correct place? Can I say that? I can. Thereby, the quick sort algorithm works. So this is the explanation and the intuition done. Explanation and the intuition. It's very simple. If I have to explain it in a shorter way, pick up a pivot, place it in its correct place, smaller on the left, larger on the right. And now the question comes, how do you do this in a code? How do you do this in the code? So this is what we will be understanding in the pseudo code, because so picking a pivot is very easy because first element is kind of easy. But now you might be thinking, but how do you place the 4 in its correct place? Because by naked eye, it's very simple. This is the sorted way. So you're seeing 4 here. So you're saying 4 will be here. How do you code it? That's where you have to understand the algorithm in depth. This is other thing that you have to understand in order to do the pseudocode. So if you carefully see, this is the entire array, right? And once you've placed 4, you go for the left and you go for the right. Now the next doubt that might be coming up to your mind is, but Striver, you have an entire array and then you're placing the pivot at its correct place. Then you're going to the left and going to the right. So do you create new arrays? No. We'll be using the concept of low and high that we used in the merge sort. Instead of building new arrays, we'll be using pointers to explain that, okay, the left array is from here to here, the right array is from here to here. We'll be using kind of pointers. So let's understand the explanation in terms of pseudocode so that we can code. So before going to the pseudocode, let's understand how do we perform these couple of steps using a bit of variables and code logic so that we can actually write the pseudocode. So imagine you're given this particular array and you have to apply quick sort to it. And this is an unsorted array. So will you be carrying this entire array? Logically doesn't make sense. Why? Because in the future, you know, these arrays will be broken down into smaller steps. So you have to recreate new arrays. So we will not be doing that. Instead of that, we'll be creating a low pointer, which will be pointing to the 0th index, which is the first guy. And we'll be keeping a high pointer, which will be pointing to the last guy. So what does low and high mean? It means the array is from here to here. Very simple. Now, what did I say? What's your pivot? So your pivot is very simple. Your pivot will be array of low. Why? We said pivot will be the first element. So the first element in the array is array of low. So first step is done. That was picking up a pivot. What's the next step? Placing the pivot in its correct place, right? So let's do it. How do you do that? In order to do that, you take an I pointer, place it at the lowest or the leftmost part of the array. And then take a J and place it to the rightmost part of the array. Done. Now you say, okay, let's find the first element which is greater than my pivot. Because if it's smaller, then it is at the correct place. But if it is greater, then we will find it. So let's find. Is 4 greater than the pivot? No. Because what's your pivot now? If I have to write the pivot is 4. So is 4 greater than the pivot? No. Is 6 greater than the pivot? Yes. So what you'll do is, you will say, okay, 6 is greater than the pivot. So you'll stop at 6. So your I pointer stops at 6. And then you will go and say, okay, let's find the first element that is smaller than the pivot from the right. I'll say 3. Are you smaller than the pivot? He says, yes, I am. So I'll stop because 3 is smaller. So you have figured out the first guy who is greater than the pivot on the left and the first guy who is smaller than the pivot on the right. Swap them. So you just have a swap. So you say 3 and you say 6. So you just swap them. Done with the swap. What is the next job that you will do? Next job, again come back and do the same thing. Figure out the first element from the left which is greater than the pivot. Is 3 greater than the pivot? No. So just go ahead. Is 2 greater than the pivot? No. Go ahead. Is 5 greater than the pivot? Yes, 5 is greater than the pivot. So I has stopped at an element which is greater than the pivot. Now go to the right and find the first element that is smaller than pivot. Is 6 smaller than pivot? No. So move. Is 1 smaller than the pivot? Yes. Stop. So 5 and 1 will swap. 1 and 5 swapped. Perfect. Let's again continue the same step. We say, okay, on the left, find the first who is greater. Is 1 greater? Is 1 greater than pivot? No. Is 7 greater than pivot? Yes. So we stop there. So it stops at 7. On the right, find the first who is lesser than pivot. Is 5 lesser than pivot? Is 5 lesser than pivot? No. So we move. Is 9 lesser than pivot? No. We move. Is 7 lesser than pivot? No. We move. Is 3 is 1 lesser than pivot? Yes. And we stop. And we stop. So we stop here. So J stops here. Like J goes here, J goes here, and J then stops here. So apparently, we stopped at a position where J has crossed I. It has crossed I. You stop. You do not swap anymore. You do not swap it anymore. Which means you are in the territory. You are in the territory where if you see everything is smaller than the pivot. And on the right, you are at a territory where everything 7, 9, 5, 6 is greater than pivot. So you stop. What's the last job you'll do? Since you stopped at 1, you just take this 4 and you place it here. So you basically say, okay, 1 and 4 goes here. So if you see what happens is 1, 3, 2, 4 is at its correct place, 7, 9, 5, 6. That is super simple. That was very simple. And we are done with this. Yes, that is how easy it was. So once you have placed your pivot at the correct index in the sorted array, can I call this as the partition index? Why can I call this as a partition index? Very simple. The reason being, this is where it's at the correct order in the sorted array. This is not in the correct order, and this is not in the correct order. It's a kind of partition. The left is still to be done, and the right is still to be done. So that is why you call it as a partition. So can I say, as of now, the low was pointed here and the high was pointed here. Can I say the new array that you have to sort according to the same algorithm is from here to here and is from here to here? So can I say the new array? One array will be low to partition minus 1, and the other array will be partition plus 1 comma high. This is where this array is this. That's it. And on this array, right? So I think you've understood the explanation, the intuition, and kind of the algorithm as well as of now. So it's time to write the pseudocode. The pseudocode is going to be very simple. We say kind of the algorithm as well as of now. So it's time to write
Oh my God, भाई, it was terrible, man. जो terrible है तो. Like मैं समझ तो आ गया, but I'm pretty sure कि मेरे कोड लर्न करने में बहुत ज़्यादा टाइम लगेगा भाई इसका, क्योंकि the fuck is this भाई? Come on.
the pseudocode. The pseudocode is going to be very simple. We say quick sort, and we know it will be given an array. And we know the array in the array that we have to sort will be from low to high. That is something which we definitely know. And we know we will only sort the array if it has more than one elements.
Right.
That means if low is lesser than high, because if low is equal to high, in that case, assume high is here, which means this is the array. One element is already sorted. So if low is lesser than high, that means it has more than one elements. Thereby, we will be sorting it. And this is what kind of the algorithm's gesture will look like. If low is lesser than high, what do we do? Imagine you're given this array. What did we do at first? We figured out the pivot, put it at its correct place, and then sorted the left half and then the right half. So what did we do at the first step? Place the pivot at its correct place and found out where it was placed and then called for the left and then called for the right. So can I say, okay, let's call a function. Right. In case means something which we definitely know. And we know we will only sort the array if it has more than one elements. That means if low is lesser than high, because if low is equal to high, in that case, assume high is here, which means this is the array. One element is already sorted. So if low is lesser than high, that means it has more than one elements. Thereby, we will be sorting it. And this is what kind of the algorithm's gesture will look like. If low is lesser than high, what do we do? Imagine you're given this array. What did we do at first? We figured out the pivot, put it at its correct place, and then sorted the left half and then the right half. So, what did we do at the first step? Place the pivot at its correct place and found out where it was placed, and then called for the left and then called for the right. So, can I say, okay, let's call a function. Let's call a function which will do that. So, I'll tell the function that for this array, low to high, please find out a pivot, place it at its correct place, and tell me where you placed it. Like for this case, you will be placing it here. Tell me where you placed it. And I'll call that as partition index. Partition index. Done. Once I've placed it partition, if low is pseudocode partition, still at the reader in the sorted array. It's a kind of partition you call it. And tell me where you placed it as once I've placed it at its correct place, I'll have other guys because after the algorithm, after the function has taken place, how will it look like? It'll look like something like 2, 1, 3, and this side it'll look like 6, 5, 7, 9. After the function has taken place. So now you have to sort this portion of the array and this portion of the array. And the partition index is here. So can I again call it quick sort? Go for the left now, which is the array. But in this array, take from low to partition index minus 1. And in the right array, take it from partition index plus 1 comma high. Again, the lines can swap. This can be at the first and then this can also be there. It doesn't matter. Even if you swap it like this, it's still okay. Because you have to sort the left and the right, or the right and then the left. Any way works as long as you are sorting it. This is simple because the recursion will do its job because recursion has been called for this. So again, it will do its job. Quite simple. But the question comes up. Okay, I understood till here. But how do we write the function? Let's understand how do you write the function. The function, remember, I'll write it with maybe yellow. The function has taken an array and has taken a low and has taken a high. And you know it has to find a pivot. And in our case, the pivot is very simple. We were saying the pivot to be array of low, which is the first element. And what did we do at every step? If you remember, we first kept a I here and we kept a j here. So let's do that. So we said I is equal to array of low. Perfect. Or maybe just write it for the index. I is at low and j is at high. This is something which we said. And what did we do? We kind of said, okay, if I is here, which is the first element, greater than pivot, and we stopped here. And then we swapped. And we kept on doing this, till I cross j. And we had a left and a right. So we kind of write, okay, while I lesser than j, keep on doing this. So we keep repeating the steps. Now, what are the steps? Find out, because I was here, then we go for the pivot. The function, remember, I'll write it with maybe yellow. The function has taken an array and has taken a low and has taken a high. And you know it has to find a pivot. And in our case, the pivot is very simple. We were saying the pivot to be array of low, which is the first element. And what did we do at every step? If you remember, we first kept a I here and we kept a j here. So let's do that. So we said I is equal to array of low. Perfect. Or maybe just write it for the index. I is at low and j is at high. This is something which we said. And what did we do? We kind of said, okay, if I is here, which is the first element, greater than pivot, and we stopped here. And then we swapped. And we kept on doing this, till I cross j, and we had a left and a right. So we kind of write, okay, while I lesser than j, keep on doing this. So we keep repeating the steps. Now, what are the steps? Find out, because I was here, find out the first guy that's greater than the pivot. So I'll be like, okay, while array of I is lesser than array of pivot, that means it's okay. This is not the guy that I'm looking for. If 4 is lesser than equal to 4, I'm not looking for you. I'm looking for someone greater than you. So this is a correct condition. And obviously, I cannot exceed the array's boundary, which is definitely high. That I'm looking for. So while array of I is lesser than array of pivot, that means it's okay. This is not the guy that I'm looking for. If 4 is lesser than equal to 4, I'm not looking for you. I'm looking for someone greater than you. So this is a correct condition. And obviously, I cannot exceed the array's boundary, which is definitely high. It cannot exceed the array's boundary. If that's the case, we say, okay, I plus plus. That means it keeps on going till it doesn't finds an element greater. So the moment it is at 6, the while loop will stop because that's where it has to. And similarly from the right, we say array of j. From the right, what do you need to find? Someone who is smaller. So if this guy is greater than pivot, then what you will do is you will say, okay, j, again, since you're going left, just say this. And you will say, okay, j minus minus. So what these lines will do is, this will find the first element which is greater than the pivot. And this will find the first element that is lesser than pivot. And at the end of the day, remember, if they haven't crossed, if you remember, then you swap them. You say array of I and array of j to be swapped. Quite simple. Array lesser than pivot is greater than the pivot. And this will find the first element that is lesser than pivot. And at the end of the day, remember, if they haven't crossed, if you remember, then you swap them. You say array of I and array of j to be swapped. Quite simple. I is greater than the pivot. And this will find the first element that is lesser than pivot. And at the end of the day, remember, if they haven't crossed, if you remember, then you swap them. Very, very simple. So if I have to show you the algorithm again, let's do a dry run. What happens? First time I stops here and j stops here. So 6 next I goes, but j obsessed when behind us is great. I swap anymore because cross die because j is at 1. So if j crosses crossed I swap anymore because your j is at 1 already at j goes crosses I do not swap anymore because you are already at the left half 3 2 1 and you're already at the right half 7 9 5 and 6. You're already at the correct halves, so you do not do a swapping. If they have crossed, they are already in the correct zones. So at the end of the day, where is j? J is at here and low is at here. So at the end of the day, when this has crossed, we stop and we say, okay, it's time for the pivot to come its correct place. So swap the pivot, which is the first element, with the array of j, which is the last element of the left index, which is the last pivot as j is at here and low is at here. So at the end of the day, when this has crossed, we stop and we say, okay, It's time for the pivot to come its correct place. So swap the pivot last element of the left index, which is the last element of the left index. You just swap it. And this will come here and this will
कैमरा
go
चालू
here.
होता.
Quite simple. So eventually what you will get is 3, 2, 1.
हम्म.
Perfect.
आलो चलो बस. यूट्यूबर बघ जाऊन.
Done. So once you've done this, what do you need to do? You need to tell them the partition index. And you know the index is nothing but j because that's where the pivot came in. So return j. Again repeat. This is how the function will look like. Quite simple. This is how the function will look like. Again repeating. This is how the function will look like. Quite
Fuck यार sorting hard आहे माहिती आहे like hard in the sense यार त्याचा कोड स्वतःहून ओरिजिन करणं खूप hard वाटतंय.
simple. This is how the function will look like. Again repeating. Find the first element greater than pivot. Find the first element smaller than pivot. Swap. Again, just swap with it. Also, before going into the code, I'll just like to mention one thing. This portion is something which we have to be careful about. And this portion is something, again, which we have to be careful about. Why? Because when you write this and you're doing I++, this might exceed the low. So this instead of high will be high minus 1. This instead of low will be low plus 1. And there is other doubt that might come into your head. Why are we doing lesser than equal to and greater here? Now imagine you had 4 and you place 3, 1, 2 on the left, and let's say 5, 6, 7, 9 on the right. 4 is placed. What if there was another 4? Then you would have either placed 4 on the left or either on the
हम्म.
right. So I will say on the left, you will
आला ना.
place everything lesser than equal to. On the right, we'll
जर्मनी.
place everything greater than equal to. That's why we are finding greater and we are finding lesser over here. Got it? Why? Because you have to decide
आओ थोड़ा कहाँ.
where do you put the equal to guys? Like if there is someone equal to, where do you place them? You have to decide on that as well. So you place it on the left. In that case, and the dry run as well because while I want you to watch my merge sort video because in that I've explained how these couple of things split the arrays and how individual stuffs work. So just in case you're not aware how in depth how sub problems are solved and everything. By the way, before moving to coding it in an online compiler, I just wanted to quickly tell you something. This is a divide and conquer algorithm because you're kind of dividing it, and when you divide it, every part is getting. Now coming into the online compiler,
No way guys, no way. My God, क्या कुक किया है भाई क्विक सॉर्ट ने क्या कुक किया है.
will be quick.
यार द थिंग इज यार ड्राई रन तो एकदम विल पावर लगा के करना ही पड़ेगा इसका ड्राई रन. चलो लेट्स डू इट गाइस. लेट्स नॉट रन फ्रॉम दिस शिट. हम्म. सो ये हमारी ओरिजिनल एरे है. हमने अपना फर्स्ट एलिमेंट. लेट्स गिव अस अ चैलेंज. अलग ले ले अपना एलिमेंट कोई. 5 लेते हैं. लेट्स डू इट 5. हमने इसको लॉक कर लेता हूँ. हम्म. लेट्स टेक आवर फर्स्ट एलिमेंट टू बी पिवट. हमारा लेते हैं हम 5. पिवट हमारा है 5. हम्म. सो मेरा एरे ये है. लो मेरा 0 है. हाई मेरा 7 है. जब मेरा लो 7 से ज़्यादा होगा तो मेरा पी इंडेक्स. ये मेरे पिवट की बात कर रहे हैं बट पिवट तो मैंने अभी तक वो डिक्लेयर किया ही नहीं ना. इस पे ध्यान देते ये कैसे वर्क कर रहा है. ये मेरा लो है, ये 0 है. ठीक है छोड़ो भाई. एज्यूम करते हैं कि 0 पे है. ओ फक. इट्स क्रेजी गाइस. इसको वापस देखना ही पड़ेगा. Let's document it anyways.
quickly coding the quick
Fuck man, like भाई ये तो beginners है लोग lol.
sort algorithm. By the way, the problem link is complexity of this is. It's giving me time limit exceeded. Why is that happening? Let's submit it and see if it's
Ah damn boy, I need to just be pretty
and we
much.
stop at right. Have to find the element that is smaller. So we go on till it is greater than pivot. Draw onto the right past of the partition index. That's how you can write the. Why is that happening? Once you've done this, you can quickly go and run this.
No shit, wait. तू रिसर्च केली त्या टॉपिकवर अविनाश? लाईक अजून एक टॉपिक आवडला ना काहीतरी बायोलॉजीचा नाही काहीतरी होता ना सस्टेनेबल एनर्जीचा त्याच्यावर रिसर्च केली एक्झॅक्टली काय आहे ओके काय होतं काय पण हम्म गॉड डॅम गाइस गॉड डॅम we are so dead guys we are so dead
And we stop at lesser than I minus 1 so that it doesn't crosses the boundary when we do I plus plus. And we also on the right have to find the element that is smaller. So we go on till it is greater than pivot, not equal to, because the equal to guys will.
even I wonder why like it's not wrong to do chat gpt but आपल्याला माहिती असलं पाहिजे माहिती आपण नक्की काय चॅट जीपीटी करतोय or else by it's fucking failure मी तर असं ऑब्झर्व केलंय चॅट जीपीटी करायला लागणारच आहे माहितीये डिबगिंग मेन प्रॉब्लेम माहितीये डिबगिंग आणि सेल्फ मॉडिफिकेशंस आई एम टॉकिंग अबाउट ये तो इम्पोर्टेंट चीज है yeah by the way guys you may lead good profile if anyone is interested to follow me well yep so yeah with this हमने quick sort complete नहीं रुक जाए टाइम कॉम्प्लेक्सिटी बचा है wait
Will be on the left. And then we go on. For the same reason, low plus 1, that we do not cross it. And at the end of the day, if they haven't crossed, let's take the right guys, put them on the left, and take the
भाई
left
तो
guys, put
याचा
them on the
विचार कर
right.
ना जरा
So swap.
आपलं तो तू कशाबद्दल डिझास्टर मॅनेजमेंट बंद कर मग नको त्याच्यावर नको फोकस करू असं आहे तर नाही होते तर
Of array of I.
मी म्हणतो यार ते एकदा फ्लो चार्ट बनव ना की लाईक आयडियली कसं असायला पाहिजे आपलं ऍप वेबसाईट तसं आहे त्याचा एक फ्लो चार्ट बनव नाही स्वतःहून वेट गाईस 2 मिनिट मी तुला हे देतो यार एक लेट्स सी माझ्याकडे आहे की नाही फ्लो चार्ट खूप इम्पॉर्टंट आहे गाईस फ्लो चार्ट खूप इम्पॉर्टंट आहे काय नाही विदाउट फ्लो चार्ट नाही चालू आहे मी तुला हे करतो सेंड करतो गॉड डॅम हे माझ्या मी सी आर कॅम्पेनसाठी मला देतो बघून काम मी तुला व्हॉट्सअपवर सेंड करतो बघ पीपीटी आपली कुठे ना कुठेतरी असं असे पाहिजे मी त्यातले फ्लो जे मी फ्लो चार्ट बनवलेत ना ते तो ऑब्झर्व कर मी तुला सेंड करतो तर लॅपटॉपवर पाहायला लागेल तुला, असं नाही दिसणार. लॅपटॉप उघड ना. हा, मग ते फक्त थोडं क्लमझी वाटेल. हा. आणि मी ट्राय करतो की मी या साईज लेवलची माझ्याकडे आहे पीपीटी, तर ती मला सेंड करेल. अँड वन मोर पीपीटी, इट वॉज लाईक आय डोंट थिंक आता ते सापडत नाही. फर्स्ट वेट व्हॉट, हे काय? void workers, like come on. ह्याला म्हणतात फ्लो चार्ट. ठीक आहे, बघ बघ, नो प्रॉब्लेम विथ इट. या ओके, सो गाइस लेट्स डू दॅट पार्ट. तो आता 15-20 मिनिटं थांबा, मी स्ट्रीम
area of
बंद
J.
करतो थोड्या वेळाने.
Perfect. At the end, once everything is done, we know J will be at the
फक्त
last
तो
of
असा
the
एक
left.
फ्लोचार्ट
So
मला रफ
swap
बनवून
the
दे.
partition. Now quickly let's submit it and see if it's running absolutely fine. It is. So now moving back to the iPad to discuss the time complexity. So the time complexity of this particular algorithm is n log n. Why is it n log n? Again, the same reason as merge sort, because every time you're kind of splitting them into two halves. Now over here, the halves are for sure getting into like something and something. Then again, this is getting into something and something. So it's kind of not getting equally split as in merge shot, but they're getting into a couple of halves. So this half will be going on like the height of the tree. If you remember, the merge shot video will be log base to n. That's how is going through the entire array space. Yes, there's a recursion stack space, but for everything. So n crossed log n. And the space complexity, we are not using any extra space. Yes, there's a recursion stack space, but let's not compute it. So this is the time complexity and the space complexity. I did not explain n log n in depth because this is a continuous course. So I'm assuming you have seen the merge sort video where I've discussed in depth
हा,
about n log n. So go back and watch it because
बघ ना, ते
over here
प्रोजेक्ट
you found
आमचा होता
similar kind of
वेबसाईटवर.
recursion calls. From a couple of things, it's log n, week of one, not taking recursive stack space into account. So that's the time complexity and space complexity. So with this, I can say I have wrapped up merge shot as well, and a couple of notes will be added very, very soon. So guys, with this, we complete step 2 of Striver's A to Z DSA course. The next thing will be step 3, where we will be starting with the arrays playlist. So guys, I hope you've understood the quicksort algorithm in depth. So just continue our tradition. Do comment understood so that I understand that you've understood everything. And also as an assignment,
हे व्हाट द फक, कुठं दिसते माणिक दादा? I अच्छा, लॉल. कॅनवा मध्ये असं असतं. सो या गाइस, दिस इज इट आज के लिए. इट्स नॉट दैट मैं बिग, बट द थिंग इज कि अब बहुत सारे काम आ गए हैं. सो या, एनीवेज. So yeah, we did its time complexity and all. Now the thing is कि यार हमें we need to goddamn drill up भाई, पता है? Yep, so I'll wait a minute, guys. या तो अभी हमारा नेक्स्ट वीक का टारगेट ये है. लेट्स ओपन इस प्लेलिस्ट मैन. पीपीटीचं काम आता लवकरच करून टाकू, आज आणि उद्यामध्ये, किंवा थोडा दिवस चाललं तरी चालते. सो या नेक्स्ट वीक का टारगेट मैंने बहुत ही आइडियल लिया है। आई होप कि मैं कर पाऊँ। सो दिस इज माय टारगेट लाइक दीज मैनी वीडियोस, बेसिकली पूरा एरे। आई डोंट नो कितना हो सकता है, मैं खुद को एग्जॉस्ट भी नहीं करूँगा फर्स्ट ऑफ ऑल। मुझे अपने ही पेस में मैं बहुत ही जैसे डेलिकेटली करूँगा, क्योंकि मैंने बहुत बार फेस किया है कि भाई स्किप किया तो हो गया भाई। एंड प्लस मेरे को फिर वो जो शॉर्ट्स बचे हैं उसका एकदम अच्छा से डेप्थ में, आई डोंट नो भाई शॉर्ट्स अभी कितना यूजफुल है, बट या 5 क्वेश्चंस ऑफ लीड कोड, यार लीड कोड मेरे को हार्ड लग रहा है पता है, टू बी ऑनेस्ट। बट आई नीड लाइक somehow grind it, I don't know how, but yeah, I need. एंड देन कोड शेप के तो मैंने सुना क्वेश्चंस इजी है, तो लेट्स डू दैट, विल डू दैट। सो विद दिस गाइस लेट्स एंड द स्ट्रीम फॉर नाउ। पॉसिबल हम रात को आएंगे या फिर we will start from tomorrow's morning. Thank you guys, thank you for watching, love you.